Welcome back, folks. I'm making this one to help you out with numbers 19 and 20 in Unit 2-2. So 19 says something about a projectile, right? There's a mass. This was given in the problem. Fired 30 degrees with the horizontal, something like this, from the top of a cliff at initial velocity given in the problem. Cliff height, 112 meters. Yours might be a different value here, but again, given in the problem. Now you'll notice it says to take y equals 0 from down here. So what they're telling you is to answer the questions with respect to a datum, which is down here. Now, part A says, what is the initial total mechanical energy of the projectile? So that is the sum of the potential plus kinetic energies when the particle is here, and you're going to get a number. Part B, suppose that the projectile is traveling at some other speed at its maximum height of 293. So part B said something about, all right, maximum height. That would put it about here in my picture. It's going to be moving this way. Let's call this maybe velocity 2 and picture 2. And write out the work energy theorem for this. All right, PE1 plus KE1 plus work equals PE2 plus KE2. And in this problem, right, if we think about a free body, here's the particle somewhere in the middle. There's a gravitational force down, no doubt. We would generally take that into account with potential energy terms. If we ignore all other effects, there'd be no work term. However, if we don't ignore effects, there would also be an air drag force, maybe this way. Now, how big that air drag force is, it depends on a lot of things. No way for me to really tell right now. It depends on the speed and the surface area and whatnot, but that's the direction it would go. If we try to include that air drag, this is an external force that you would have to take into account in the work term, because there is work being done. So the question says, how much work did it do? So this is really what it's asking for. So your PE1 plus KE1, that's a number that you already have from part A. At position 2, they tell you enough information to calculate your PE2 and then your KE2, and then you can solve for this. So that should get that. That should get that done. Okay, part C is about when it hits the ground. So let's just extend this. Here's part 3. Write out a work energy theorem again. Maybe a PE2 plus KE2 plus work from 2 to 3 equals PE3 plus KE3. There should be enough information to get the PE2, right, mgh. There's enough information for the KE2, right, 1/2 mv squared. If this force stays put, you're going to have a work term, and they tell you something like to assume that that work is half of what it was before. So you're going to take your answer to part B, and you're going to use half of that here. And that's just, what they tell you to do. There's no way to really know that in an actual problem. But PE3 is going to be 0 because you're at your datum. KE3 1/2 mv squared. That should get you through 19. Let's talk 20. Get rid of some of the stuff here. All right, so in 20, there's a slide-looking thing. Something like this. And here's this particle up here at part A. And then there's a bunch of heights given. I think this says height at A. Here's B with a given height at B. Here's C with a height at C. So, let's see. What's the speed at B? So write out a work energy theorem between A and B. And you're going to have a potential energy A, and you could go ahead and just use this height using a datum here. You're going to have a potential energy at B. And you'll have a kinetic energy term as well to get that speed. That should be almost no problem. As far as finding the speed at part B, you can write another work energy theorem. And you can either do B to C, let's see, or A to C, it doesn't matter, either one. And then fill in the appropriate kinetic and potential energies. You'll get the speed at C from the 1/2 mv squared term. Okay, part B, where it says what is the work done by the gravitational force when it moves from A to C? There's a couple ways to calculate that. Here's one. So work is force times distance. The distance you need is this vertical displacement right there. And the force is the weight mg. You can also get it from the difference in kinetic energies between these two locations. I'm sorry, the difference in total energies, not kinetic energies, but the difference in total energies. So, actually, I'm sorry, let me go back. Difference in kinetic energies, that's what you would want to do. That would give you the work done by the gravitational force. Well, I would just take the gravitational force times this distance right here will tell you the work done. So that should get you through a number 20. I'm going to call that a day. Call that good and have a great day.